Hi, I'm Sven. One more thing about flow location problems. Well, that sounds quite nerdy. But what about this one? One more thing about how to feed a hungry crowd and take down a gang of smugglers. Based on the same technique. Better. Welcome to Obtaino. There is one thing that our optimization specialists really love. When they combine well-known techniques to solve new problems in an unexpected way. And this is the case for flow location problems. We all know about flow network problems. We maximize the commodities sent over a network of trucks between warehouses or customers. There are restrictions we must respect, most often due to transportation capacities or missing connections. That's day-to-day business. And there is the famous facility location problem. Where to put our new warehouse to serve everyone the cheapest way? Where to build a new wind turbine? That's also day-to-day business. And now for something completely different. Imagine a stadium hosting a big event, and there is a break in between where everyone is hungry, rushes out, tries to get some food, and rushes in again just in time for the next part. Actually, modeling the corridor layout is a kind of flow network problem, where we want to maximize throughput, that is, as many people as possible can move around at the same time. Now we need to feed the crowd. But if we put food stalls just somewhere, well, they will be probably just a hindrance and lots of people will be late when the show continues. So where to put these food stalls? This sounds like a facility location problem, but it's not, because a location decision will also impact the flow of the people. Enter flow location problems. This rare representative of models adds a certain type of restriction to the available flows, a dependency of the flow capacity to the number and size of the food stalls, so to speak. This way, we can find an optimal way to place food, while still letting the people move around as freely as possible. But what about this gang of smugglers? Well, a flow location problem is about maximizing the flow while strategically placing some blockers, such that the impact on the flow is as minimal as possible. And now we turn that around. If we think about a network of contraband connecting dealers and other criminals, then this is a network we want to disturb, right? So we treat police actions as blockers and try to strategically place them on the network. The objective is to find a placement such that the overall flow of the network is impacted as much as possible. This is closely related to flow location networks and called an interdiction problem. Same idea, totally different application. Weird stuff. It's one of the highlights for optimization experts when we can combine existing techniques to solve a new problem that might not be as strange as it may seem at the beginning. This is the case for flow network analysis and the facility location problem. Combining them both to flow location networks and interdiction models tackles a new type of problem, being it food stalls or crime fighting. I always love to discuss applications like that when our specialists run wild. See you next time and stay safe.